Okay, third time will be a frickin' charm with this. I've already tried 3 times to make a little bit to end this little movie. I think I threw my pen in disgust at the last one because I kept getting text messages scheduling the exterminators and all that kind of crap. All right, but anyway, the whole point of this class is that, and one reason I really enjoy teaching it is that I see students that have suffered long and for years in math and science classes because they just didn't get the math part, or they hated the math so much they wouldn't get into it. But now they're starting to see, oh, it's not so bad if I can just fill in enough, if I don't have to do the arithmetic and just can kind of conceptualize things, you know, and then we'll do some really heady algebra stuff here. So, and it's great. In fact, I just had one of your fellow students in my office today, and she knew what she was doing. We figured it out. She actually knew what the heck she was doing, and she just didn't know she knew. So anyway, so Professor Splash, 90 kilograms. I'm guessing that's probably what around there. The acceleration due to gravity. So, what is the force? F equals ma. We know that gravity now. So F equals ma. So here we go. So the force would equal 90 times 9.8, and we're going to leave everything in, so that's how you get the force. All right, so then, and I've also noticed that on these, I've been cutting out the videos where I actually kind of work through some of the problems, and you're looking at the problems as if I put them on canvas here. So what is his speed when he hits the water? All right, so right away we jump right into, so what's his speed when he hits the water? You might be going, well, I don't know. Well, we know the work that was done, okay, when he climbed up that ladder. So here's what happens. He climbs up that ladder. So the work is equal to force times distance. Here's the force. The distance is whatever you got, the 12.9. I'll just tell you. It's 12.9 right here, okay? So you take this force times this distance. That equals the gravitational potential energy. So he's ready to do that. You know, he did work to get up there. Now he's got this potential energy and he's ready to come crashing down with the kinetic energy. And so we learned that his speed, because we knew that mgh is equal to 1/2 mv squared. And we've already done this problem once before, where we know that v is equal to the square root times 2 times g times h. Okay? Now, if you don't have a square root key, if you don't have a fancy square root key on your calculator, you go 2 times 9.8. times 12.9, and then you hit that little square root key, okay? And it should give you what his velocity is when he hits the ground. All right, now what we're going to do is what we do in physics all the time, is what we do in science all the time, is we're going to, so what's the speed upon hitting the water? Now, what is Professor when he hits the water? So what's his kinetic energy? Again, like I said in the previous thing, so his kinetic energy is equal to 1/2 his mass, 1/2 of 90, times whatever you got here. Square. Well, actually, you could just put times, because 9.8 times the square root of that, you could actually just put those numbers in. But whatever you got for the velocity, and then multiply it again if you don't have a square key. You can just do it that way. That's fine. So you wind up with 45 times the velocity you got up here times the velocity again. No biggie. You got this. You got this. You're golden. Don't use commas or scientific notation in your answers. Okay, so that's good. So this is pure speculation on my part. Now, let's assume he goes 0.32 meters when he hits the water. That's how far down he goes, like about a foot. All right, because they said that, I think they said there's 18 inches of water in the thing. And he didn't kill himself. So, so when he does his belly flop, remembering that that the kinetic energy is equal to the force times distance. Remember, because up here, look what we did. We did force times distance to get us our gravitational potential energy, and this equaled the kinetic energy. So he comes crashing down with his kinetic energy, and that equals the force times the distance. So we want to know what the force was that he hit the water with. What was the force that brought him to a stop, actually? Okay. What is the force? And then we could go in and we could look at we could analyze the video and figure out the time, and we could find an acceleration and all that kind of stuff, and what the impulse was. We could do all kinds of things with this. But you got the kinetic energy above, and now you're going to do the force times distance. And so to get the force, you take that kinetic energy that you got before and divide by the distance, by the 0.302 meters, and you're golden. You've got it. All right, so there's the Mr. Splash stuff. Okay, out here. Oh, I got to hit out here.